Hello students, welcome. Previously, lesson 10, form 3, topic 4, we were dealing with the third part of ammonia gas, where we have done reaction of aqueous ammonia with metal ions or cation ions. So today, lesson 11, we will be proceeding to the fourth part of ammonia gas, where we are going to see the first part of the chemical properties of ammonia gas, and we are going to start with number 1. And we're saying effect of ammonia on litmus paper. So we're saying ammonia gas turns most red litmus paper to blue and has no effect on blue litmus paper, meaning the blue litmus paper remains blue. And the reason for this is that this is because ammonia is the only basic gas or the only alkaline gas. So when we're having the gases that we have in the lab, they're of three. We have neutral gases like oxygen, hydrogen, nitrogen gas. There are very many. Then number 2, we are having acidic gases. They include carbon dioxide, sulfur dioxide, chlorine gas. There are very many again. Then next we are having basic gases. We have only one basic gas in the lab, and that is ammonia gas. Number 2, we are going to see reaction of ammonia with dilute acid. When we are talking about dilute acids, there are of three: dilute hydrochloric acid, dilute sulfuric acid, and dilute nitric acid. So I say an aqueous ammonia solution reacts with dilute acids to form ammonium salt and water. So examples, when we are talking about aqueous ammonia, it's ammonium hydroxide solution reacting with hydrochloric acid or dilute hydrochloric acid. What we are going to get is ammonium chloride solution and also water. Then next we are having ammonium hydroxide, 2 moles of ammonium hydroxide reacting with 1 mole of sulfuric acid. We are going to get ammonium sulfate plus water. Then number 3, we are having ammonium hydroxide solution reacting with dilute nitric acid. What we are going to get is ammonium nitrate and also water. So next we are saying if dry ammonia is used or is bubbled through dilute acids, ammonium salts are formed. So the difference between these two is that when we are having aqueous ammonia or ammonium hydroxide, we are going to get salts and water. But when we are talking about dry ammonia, that means ammonia gas, and it reacts with dilute acid, what we get is only one product. That's ammonium salts only. So examples: ammonia gas reacting with hydrochloric acid, we get ammonium chloride solution. That's the salt. Number 2, 2 moles of ammonia gas will react with dilute sulfuric acid, and we're going to get ammonium sulfate solution. Then number 3, we're having ammonia gas reacting with dilute nitric acid. What we are going to get is ammonium nitrate solution. So next, let's proceed to the third chemical properties of ammonia gas, that is reaction of ammonia gas with air, and we are talking about oxygen. So part A we are going to do in the absence of a catalyst. So that means we want to see the reaction of ammonia gas with air in the absence of a catalyst. So we're saying ammonia gas does not burn in air. However, it burns with a greenish yellow flame in air enriched with oxygen to form nitrogen and steam. So the equation for that reaction will be 4 moles of ammonia gas reacting with 3 moles of oxygen gas. What we are going to get is 2 moles of nitrogen gas plus 6 moles of steam, which is also a gas. So we are going to use this setup to see the reaction of ammonia gas with air in the absence of a catalyst. So we're having dry oxygen here and we're having dry ammonia gas on this other side. Then here we're having glass wool. This is a glass wool and we are using wide glass tube, and this is the flame. It is burning with greenish yellow flame. So let us see, note, we are saying the role of the glass wool is to spread the oxygen evenly. So here is where we're having the glass wool, it is here, and here we're having oxygen. So the role of this glass wool is to spread the oxygen, this dry oxygen, evenly, so that it reacts with this ammonia gas to form nitrogen gas and steam. So part B, we are having in the presence of a catalyst, and in bracket the catalyst that we are going to see or to use is platinum catalyst. So we are going to use this setup. Here we are having concentrated ammonia solution. It generates ammonia gas, and here we are having oxygen gas, and when they react we are going to see red brown fumes as one of our observations. So we are saying in the presence of a catalyst, ammonia will react with air to form nitrogen 2 oxide and steam. Kindly know the difference. When we are talking about in the absence of a catalyst, the products were nitrogen gas and steam. But when we are having the presence of a catalyst, the products are nitrogen 2 oxide and steam. You have to know the difference. So we're saying the catalyst used in this reaction is platinum catalyst. If we don't want to use platinum catalyst, we can use copper wire catalyst, or we can use nickel rod catalyst. So the question for that reaction will be 4 moles of ammonia gas reacting with 5 moles of oxygen gas in the presence of a catalyst, either platinum catalyst or copper wire catalyst or nickel catalyst. What we are going to get will be 4 moles of nitrogen 2 oxide gas plus 6 moles of steam, which is also a gas. So next we are saying the observation made when ammonia reacts with air in the presence of a catalyst is red-brown fumes. And the reason is that we are saying this because nitrogen 2 oxide is a colorless and is readily oxidized to form red-brown fumes of nitrogen peroxide gas. So the question for that reaction will be 2 moles of nitrogen 2 oxide gas, which is a colorless gas, will be reacting with oxygen gas or will be oxidized by oxygen to form 2 moles of nitrogen peroxide gas, which are red-brown fumes or which are red-brown in color. So next we will be proceeding to the extended questions. We are having 2 extended questions. We are having number 1. You can see the questions. Just try to answer it. We proceed to question number 2. This is question number 2, and learners, that is the end of our class for today. Thank you for watching.